Hello all, once again, welcome back to our lectures. Today we'll be talking about unsaturated hydrocarbons. Particularly, we'll be looking at the nomenclature of alkenes. So the first alkenes are the first class of hydrocarbons. So we'll be specifically looking at their nomenclature and including other what we call their isomerism as well. Their cis and trans isomerism. So those are the things we're going to be dealing with this class. As usual, traditionally, I always give you my quotes. If you don't give up, you still have a chance to win. Giving up is great failure. This is from Jack Ma. Jack Ma, it's a billionaire tech entrepreneur. And we know about him. All right, I'm not going to say much about that. Let's just take it off immediately without wasting time. Now, the learning objectives for this particular lesson include: number one, we're going to classify unsaturated hydrocarbons as alkenes, alkynes, and aromatics. Those usually I've shown you this thing earlier when we talked about. I remember that when we talked about the hydrocarbons generally. So the alkenes, the alkynes, and the aromatics, they are the unsaturated hydrocarbons. The only one class of the saturated ones are the alkenes, which we talked about in the previous models. And then we now use IUPAC nomenclature to name alkenes and draw their structural formulas. And then finally, we also name and draw structural formulas for the geometric isomers. Alkenes undergo, in addition to structural isomerism, alkenes also undergo geometric isomerism, which is a type of stereoisomerism. So we're going to look at, these are all what we're going to be looking at as we move on in this class. Let's just move on immediately. Unsaturated hydrocarbons. Now, unsaturated hydrocarbons are those hydrocarbons that contain at least one or more double or triple bond between the carbon-to-carbon bonds. Remember, in organic chemistry, like we defined, the study of carbon forms this long chain. When this long chain becomes a double or a triple bond, we're talking about unsaturated hydrocarbons, and that is basically what we're going to do. So there are three classes. Now, when alkenes are the class that contain, for the alkenes, they contain one or more double bond between those carbon-to-carbon chain, carbon-to-carbon double bond. There will be double bond. And they are derived from a general formula, CN, H2N, the unbranched ones. Like again, they make up what we call the homologous series. We did this in the previous lecture too. Now, alkynes contain one or more triple bonds. The alkynes are the ones that contain carbon-to-carbon triple bond, and they are derived from the general formula CN, H2N minus 2. And the last group are the aromatic hydrocarbons. The aromatic hydrocarbons contain 3 double bonds in an alternating ring. That ring, we call it the benzene ring. This is usually what we call the benzene ring. The benzene ring has, now, what we say alternatives. You have a double bond here, you jump this one. You have another double bond, you jump this one. So it alternates. And in fact, it undergoes resonance. We're not going to be talking much about resonance at the level of this class. But this thing alternates. Why does it alternate? Now, remember the double bond was there. It's going to start here now. It's going to jump to this one. This one now is going to jump one angle. So you find out that in this side, there's a double bond at this point. Here there was single, there was a double bond, and here again there was a double bond. So it's an alternating double bond. So what we're saying is that the aromatic groups are based on the benzene ring. And these are the three classes. The alkenes are the saturated, these are the unsaturated. So in this module particularly, we'll be focusing on these three classes: the alkenes, which have carbon-to-carbon double bond. The alkynes, this is a good example. This is an 18, this is 18. This is 18. Then the alkynes, this is an example of an alkyne with the simplest. It's called a thine. And then the aromatic, this is the benzene ring. So these are the three classes we're going to be focused. So let's take it off from there immediately. Now let's get into it. How do we name alkenes? So let's look at the alkene nomenclature. Now remember, when I talked about the nomenclature of alkenes, I told you that the nomenclature of alkenes is the basic understanding and introduction to the general nomenclature. Like we're going to be talking about the IUPAC prefixes of the met, the et, the prop, the but, the pent, the hex, the hept, the oct, the non, the deck. We're going to be talking about those. So we cannot leave them anymore. That is the foundation. So anytime we talk about the longest chain. So we're going to be tapping from the understanding of that to build on any other nomenclature as we move on. So how do we name this? What are the rules? I have a couple of about 5 rules here we're going to look at again. First, we have to identify and name the longest chain. So the longest chain again is where it takes its rule. Remember, every nomenclature focuses on getting the longest chain that contains that particular functional group. Remember here, for the alkenes, the functional group is the double bond. Remember that. So we name the longest chain that contains the double bond. So your interest in the longest chain is the longest chain that has the double bond. And then you now use the IUPAC root name and the end, the ENE. Remember, we have the IUPAC root name, like I said again, the met, the et, the prop, and all the rest of them. Now, instead of saying, okay, remember, if we have propane, remember, we're going to say propane. Now, you're not saying this. What are you going to do? You're going to be replacing ANE with ENE. So if we replace this, what is it going to be? We're going to be having, okay, let's use my rest. So it's going to be prop, which is the prefix, the IUPAC prefix. What are we going to do? We're not going to put ENE. It's going to give you propene. So this is exactly what you're going to do for the longest chain. All right, we now continue. Now, you now number the longest chain so that the carbon with the double bond gets the lowest numbering. Now, remember when we talked about alkenes, the lowest numbering were done because of the attachment. No, here it is not. The double bond gets the lowest numbering. That is what decides where you number from. Then the next one, the third one, you locate the double bond with the lowest number. That numbering you did, you now locate it with that lowest number. Again, don't forget you may have an attachment. You now locate and name the attachment at the groups again. Then combine all the whole names together and you come up with the name of an. I have an example here. Let's look at this structure now. The first thing I want to do here is to know the longest chain. I already numbered it myself. So if you look at this now, there is 1, 2, 3, 4. There is 1, 2, 3, 4. All these are longest chain, 1, 2, 3, 4. Now, which direction am I going to count? The direction that gives the double bond the lowest number. If I count from here, 1, 2, my double bond is carbon number 2. 3, 4. If I count from 1, 2, so whichever side I count from doesn't matter. In this case, now what am I going to do? I'm going to shift my attention. Which direction now will also help out the attachment with a lower number? If I come from here, okay, let me use a different color. If I come from 1, 2, 3, 4. Okay, let me put that one down. 1, 2, oh, that 3 is 4. Okay, 3, 4. Look at what is happening here. If I come from here, my attachment, granted, my double bond gets number 2 and gets number 2 from here. But my attachment gets number 3 from here. This is my attachment. It gets number 3. Whereas, if I count this way, it gets number 2. So this, counting from this direction becomes the correct one. So what does that mean? I'm going to jettison the counting from this direction. So I'm going to ditch this counting. I'm not going to use it. I'm going to use this one. So if I have used that one now, I've given this the lowest number, which is my attachment. And I've also given, before even the attachment, I've given my double bond the lowest number in carbon, in number 2 carbon. So how do I name it? And I put. So the longest chain is butane. Remember, it's butane. What do? I'm going to change it. I'm going to remove this EN, therefore it's going to be butene. That's what it is. But this is not the name. So what else am I going to do? Remember, we're not working with this. This is not what we're working with. Now this is what I'm working with. So I go back to it again. So that, let me make it a little bit. Yeah, I'm going to write it here. So this is butene. That's what I have. Now, where's the double bond located? The double bond is located in carbon number 2. So it's going to be 2-butene. 2-butene means it's a long chain without attachment. However, remember, the attachment comes first. So where is the attachment located? It's located in carbon number 2, and this is a methyl group. So it's going to be 2-methyl. Okay. I need some small space. I write big. That's fine. So it's going to be 2-methyl 2-butene. That becomes the name of this compound, as we see. So that is exactly what we're going to apply as we move on with the rest of this class in the nomenclature. Let's take it off from there. I have a couple of reflection questions we're going to be dealing with. The first one says, name the following alkenes. Please, this is a mistake. I just saw that now. This is alkenes, please. Name the following alkenes. That is the first thing we do. Let's pick it up. I have a table that has 4 alkenes there, so we're going to be naming it. Okay, first thing first, for the first one, what do? We're going to number the longest chain. Now, I can count from any direction, but remember, my interest is which direction is going to give me the lowest number to the double bond. If I counted from here, 1, 2, 3, 4, my double bond will have 4. I'm not going to go with this direction. I'm going to count from here. So I'm going to count from here. 1, 2, it gets 2 because here I gave me 4, but here I gave me 2. So 1, 2, 3, 4, 5, 6. It has 6 carbon. Granted, we don't have any attachment. That makes the job easier for us. So what do? We're going to name it straight. What do I do? So since this is 6, what it means is that I'm going to move the A and E and put E and E because of this double bond. So this is hexene. That's exactly what this is. Where is the double bond located? It's located in number 2. Between 2 and 3, you take the first one that comes. So it's in number 2. So this is going to be 2-hexene. That is how we name that. All right. When I go to the next one, okay, I'm going to go to this one first. So I'm going to say this is my A, this will be my B now. Naming this one now. How do we name it? Again, we count. Remember, let's see what happens. If I count from here, 1, okay, see, let me show you something interesting. 1, 2, 3, 4, 5. This is a long chain. But there's no double bond here, so you cannot do this. You can't do this. So I'm going to take it off. So I'm going to say, no, this can't be done. I'm going to take it off. I'm going to take it off. This can't be done. Right? So I'm going to do the right thing. Because where the double bond is, if I come from here again, 1, 2, 3, 4, 5. The double bond can get 4. But I can come from here to give it the lowest number, to give it 1. So if I come from here, it's going to be 1. Okay, no, I'm going to try to use my color. So this is 1, 2, 3, 4, 5. It gives it 5. Because if I come from here, 1, 2, 3, 4, it gives it 4. So that numbering will be wrong. If this is my longest chain, I haven't identified it, what it means is that this is an attachment. Remember that this is an attachment. And this attachment is a methyl group. Remember, it's a methyl group at that point in time. So here now, this is a branched alkene. And we have an attachment. And I already have my longest chain. So this is pentene. So let me first of all write it to the right. So this is 5 means pentene. Where is my double bond located? It's located in carbon number 1. I'm going to put it -1. Where is my attachment? In carbon number 2, 1, 2. This is 2. So it's going to be 2. Give myself some space. It's going to be 2 metal 1 pentene. That is how we name that compound. Let's take this one now. This one has 2 attachments. That will be more interesting. Let's see. Now, if you look at this double bond is close to this way. So that tells you that we're going to count from here, not from this. If you count it from here, this is the longest chain, basically. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5. This is not the long chain. 1, 2, 3, 4, 5. So I'm going to be counting from here. If I count from here, the number gets too long. So if I count from here, this becomes 1, 2, 3, 4, 5, 6, 7. 7. That's the longest chain. So what does that tell us? We have how many attachments? We have 2 attachments here. We have bromine. This is bromine at number 5 and methyl at number 4. Now, so what do? If we come from here, remember now, methyl is in number 4, bromine is in number 5. But how do we going to arrange them? Alphabetical order comes in place. B comes before M. So we're going to put our bromine first. And again, remember, this is the longest chain is heptene because this is the longest chain. And the double bond is located in number 2. So this is going to be 2-heptene. So I want to combine everything together. So it's going to be bromine is going to come first. Despite is in number 5 because alphabetically bromine comes, B comes before M. So it's going to be 5 bromo, 5 bromo, 4 metal. Methyl group is in number 4. 4 metal. And then we don't have any attachment. We now name the longest chain. What's the longest chain? Is heptene because this is 7. Where is it? Where is the double bond located in carbon number 2? So this is going to be heptene. 5 bromo, 4 methyl, 2 heptene. That is how we name this. Let's name this one quickly too. Now to name this again is going to be, again, you see this now, this is an attachment. This is a nitro. This attachment is nitro. But the double bond is closer to this. So it's going to be number 1. So this will be 1, 2, 3, 4, 5. So the nitro groups are attached in number 5. So it's going to be, and the longest chain is 5. So it's pentene again. So we're going to have 5. This is the carbon number 5. 5 nitro. The longest chain is pentene, but the double bond is in carbon number 1. So it's going to be 1 pentene. 5 nitro, 1 pentene. This is how we name these alkenes. Let us move on from there. Now, how do we name cycloalkenes? Cycloalkenes will follow almost the same nomenclature. What's the difference? Now, we must religiously label the double bonds because this is a cyclic compound. We're having a ring, right? The double bond has to exist, usually it exists between 2 carbons. Those 2 carbons, we're going to give them 1 and 2 all the time. So we number the carbon atoms of the ring double bond 1 and 2 in a direction that gives the substituent encountered first to the lowest number. You make sure that the substituent encountered first gets the lowest number, even while you are numbering those 2, 1, 2. Then we now number and list the substituent in alphabetical order again. That will always come into play. Let's see how this works here. Look at this. Now, this is 1, 2, 3, 4, 5. So this is cyclopentane. Because we're not going to say cyclopentane because of those. So it's going to be cyclopentene. Now, when there is only 1 double bond, we actually don't need to locate it because we know it is just 1 double bond. But if it's more than 1, you can now begin to locate it. And we're going to talk about that after this slide. Now, this is cyclopentene. Where is this located? Now, let's count. Now, this gives it 1 and 2, like I said here. But I can also decide to count this with 1. You can do 1, 2, 3, 4, 5. If you do 1, 2, 3, 4, 5, it still gives you 1 and 2 between this. But look at the error you are making. The error here is that the attachment is the methyl group. The methyl group here gets number 5. You now have 5 ethyl, 5 cyclopentene. That is wrong. You can name this because you have to count in a direction that also considers that although we know our emphasis lies on the double bond, you have to consider the attachment as well to give it the lowest number possible through the direction of that double bond. So therefore, this counting is not going to suffice. What are we going to do? We're going to remove it. I'm going to remove that numbering. It is not the right numbering to do. So again, it's going to be, if you count here, 1, 2, 3. So it's going to be 3. This is going to be 3 ethyl cyclopentane. Remember, you don't have to put a hyphen between alphabet. It's only alphabet and a number. Or when you have a capital letter as a location. We're going to talk about that by the time we talk about amines and amides. So that is exactly how you name. So this is not correct. This is the correct one. Now, what about alkenes with multiple double bond? When an alkene have more than 1 double bond, you have to tell us the position of that double bond, even whether in a cyclic alkene as well, a cyclic alkene. So usually the name will not end as "in" now. It's going to be ending. When it has to, it's going to become diene. When it has to, it's going to become triene. When it has four, it becomes tetraene, pentaene, and all the rest of them. So that is that. So what it means is that those double bonds are named as alkadienes and alkatrienes. So you have to indicate the location of the multiple double bond as well. Let's use this as an example. If you look at this now, this is it. We can name this. Now again, remember, I like giving students these options for numbering. That's usually the mistake students make. So if I number from here, this is 1, 2, 3, 4, 5, 6. I have 6 numbering. And here, look at what happens. My double bond is between number 2 and number 1, 2, 3, 4, 5, 6. Yes, number 2 and number 5. This is wrong. Whereas if I come from here, it is between number 1 and number 4. Therefore, this numbering is not going to suffice. What do? I'm going to take it off just to let you know that those are possible errors that students do. So I'm going to number it from here. If I number it from here, what it means is that this becomes an attachment. Remember, this is the methyl group, so this is an attachment. So I'm going to say the location of this. So this is going to be in carbon number 2, 2-methyl. Where are the double bonds located? The double bonds are located in carbon number 1 and carbon number, remember it is located here, and carbon number 4. So it's going to be 2-methyl. Then we say 1, you have to separate a number and a number by a comma. 1, 4, that means 1,4-hexa. Remember the name, the ending will end, instead of saying hexene, it's going to be 1,4-hexadiene. You have to factor this as a diene. So that is how we name these ones. Let's do some other reflection. We say, what is the name of this compound? Again, let's remember, you have to, when you have a cyclic one, you have to give both of them 1 and 2. So if I number this now, there is the wrong numbering. I'm not going to go to that just because of time. If I do the wrong numbering now, I'm going to say 1, 2, 3, 4, 5. That means this is going to be 1 and 5. It can be, because I have opportunity to number it this way: 1, 2, 3, 4, 5. That means I'm giving fluorine attachment 2 and 3. So if I have that option, I shouldn't go for the longer option. So what is going to be the name then? It's going to be, like I said, if you have only one double bond, you don't need to say where it is. In a cyclic alkene, you don't need to locate it when it's just one. Just put the name, because we believe the understanding is that it is one and is equivalent. But when it is more than one, you have to say the locations. So what it means is that this is a cyclopentene. This is a cyclopentene. That's what it is. Assuming there's no attachment, it's a cyclopentene. Now, where are these things attached? It's attached in carbon number 2 and 3. And it is the same fluorine. So it's going to be, okay, I don't have enough space here. I'm going to write it here now. So it's going to be 2, 2 and 3, 3 difluorocyclopentene. And when you look at the options you have, in the options we have, it is this one that satisfies 2,3 difluorocyclopentene. This becomes the correct answer. We'll now go to the next slide. No, I have a lot of reflection questions we're going to be dealing with. Now, in this reflection, we say name these alkenes again. Now, let's name these alkenes. Let's quickly go. Remember again, we have to put the double bond in the longest chain. If you look at this now, I can number this thing 1, 2, 3, 4, 5, 6, 7, 8, 9. This is the long chain, but the double bond is not there, so I'm not going to go with that. I'm going to go with this one. If I can also number it this way: 1, 2, 3, 4, 5, 6. This is 6. Is that the longest chain? But look at this attachment. No, it's not going to be correct, because you need to factor this attachment. Therefore, I'm going to number it this way: 1, 2, 3, 4, 5, 6, 7. That is the longest chain. So what it means is that I have how many attachments here? I have 3 attachments. I have methyl group here, bromine, and 1, 2, 3, 4, a butyl as attachment. So I'm going to factor all of them in. So what it means, my longest chain is heptene. So it's 7 heptene. And the double bond is located in carbon number 1. So it's going to be 1 heptene. Now I'm going to combine everything together. Let me combine. Again, let's see which one comes first. Bromine, methyl, and butyl. So between Br and Bu, Br comes first. So, and this is carbon number 6. So I'm going to start 6. Maybe I'm going to use blue this time. So this is going to be 6 bromo. 6 bromo. After B, what comes first? Butyl. Butyl is in number 3. 3 butyl. 3 butyl. What attachment is follows? Methyl group. Methyl is number 5. 5 methyl. And then 5 methyl. We know this, the longest chain is heptane, is hept. And because of this double bond, it's going to be E and E. And it's located in carbon number 1. So it's going to be 1 heptene. So that is how we name this compound. 6 bromo, 3 butyl, 5 methyl, 1 heptene. Now let's go for this one. Now, if you look at this one again, remember the 1 and 2 stuff. Now let's see. So this is the ring cycle. This is cyclohexane. Remember, 1, 2, 3, 4, 5, 6. Cyclohexane. Where is this located? We have to count it 1 and 2. So if you count it 1 and 2, 1, 2, 3, 4, 5, 6. This becomes number 6. It's a wrong number. So we have to help this isopropyl. Remember, this is, okay, well, let me change that color. This is isopropyl. Isopropyl. So isopropyl need to get the lowest numbering. All right? So let us not forget that. So like I said, we got our isopropyl here already. We got our isopropyl here. So what else we do? We know this is isopropyl. Oh, that isopropyl is not correct. I'm going to write it. This is isopropyl. Yeah. So now we have to give this 1 and 2, remember, in the rule. So this is going to be 1, 2, 3. Because if we count from 1, 2, 3, 4, 5, 6, it's going to give the number 6. But here I gave you number 3. So this is going to be the correct. So 1, 2, 3. This is going to be 4, 5, and 6. So again, it's only one double bond. We don't need to say where it is. We're good. So this is cyclohexane, and this is located in carbon number 3. So it's going to be, again, let me use my blue. So it's going to be 3 in number 3. 3 isopropyl cyclohexene. Remember, cyclohexene. Again, no need to locate the position of the double bond because it is only one. Now, we're going to do the opposite of that with this next problem. Let's now do this. Now, in this one, let's count first. Now, this has 2 double bonds, so we have to locate the position of the double bonds. And let's count the number first. So if I count from here, 1, 2, 3, 4, 5, 6, 7. So this is 7. Where do I count from? We have to give it 1 and 2, and then 3 and 4. That's what it means. No, 1, 2, and then another. The next double bond should be located pretty close. Now look at this. If I give this 1 and 2, okay, I'm going to just count this. If I say 1, 2, 3, 4, 5, 6, 7. Look at, I have this 1 and 2, and I come and give this 6 and 7. That is the correct wrong number because we have to consider a double bond. So what am I going to do? I'm going to take it off. I'm taking this off, so I'm taking it off completely because it is a wrong number. Now, what am I going to do? I'm going to now do the right number. The right numbering will be to count it this way. 1, 2, 3, 4. You see, this gave it now 1, 2, and 3, 4, which is better. So 4, 5, 6, 7. Now, let us now put everything together. If we put everything together, what do we have? We have methyl group in carbon number 1, chlorine in carbon number 5. Now, M and this, which one comes first? C, M and C. C comes before M. So we're going to have, let's just name it. If I take my blue, so it's going to be 5 chloro. The next one is going to be 1 methyl, because this is methyl group. This is, remember, this is chlorine here. 1 methyl. And then we have 7. 7 means cyclo what? Heptene. Cycloheptene. But here, we have double bond in no. So you're going to put the first numbers of the double bond. Here we have what? 1. And we have 3. So it's going to be 1 in carbon number 1 and carbon number 3. So we're going to have 1, 3. We'll now put our cyclo. Remember, cycloheptadiene. 5 chloro, 1 methyl, 1 3 cycloheptadiene. That is the name of this compound. Let's now talk about the last one there. In the last one there, what do we have? Now look at what we have in the last one there. We're going to number this. Already, if you number from here, this gives this 1, 2, 3. Here, this gives 1, 2. So I'm going to go this way. So it's going to be 1, 2, 3, 4, 5, 6, 7. 7. That's the longest chain. So this is not cyclo now. This is just heptadiene because there are 2 attachments. Now, there are 2 double bonds. And there's an attachment in carbon number 3. What's this attachment? Remember, this is what? Tet. I told you Christmas tree, tet butyl. That's what it is. So let's name it. How do we name it then? We're going to name it this way. So it's going to be, I'm going to try to squeeze it in here. So this is going to be, the longest chain is heptadiene. Now, but where is this located? So this is going to be 3-tet-butyl. 3-tet-butyl. The double bond is in 2 and 4. So it's going to be 2, 4 hepta. There are 2 of them because it's 2,4. We've used 2,4. Telling us there are 2 of them already. So it's going to be heptadiene. So that is how we name this compound. We now go to the next, the last concept in this particular lecture will be geometric isomerism. So geometric isomerism is just the difference in the orientation in space. Now, in this case, geometric isomerism is possible because there is no free rotation between the carbon-to-carbon double bond. The carbon-to-carbon double bond here doesn't have a free rotation because unlike the alkenes that have free rotation. Now, this results to 2 types of isomers that we call, because you can actually turn it a little bit. That turning results to 2 types of isomers, what we call the cis isomers and the trans isomers. Now, the cis isomers is that you must have 2 groups or 2 attachments on the same side of the double bonded carbon. Whereas for the trans, you have the 2 groups on opposite side. Now, the cis-trans isomerism is only found in alkenes that have 2 groups, 2 different groups attached to the carbon-to-carbon double bond. Now, let's look at this. If you look at this now, this is attached between the 2. Remember, the double bond must be between 2 carbons. So those 2 carbons that have the double bond will have 2 different groups attached to them. That is the only way this is possible. Now, look at what happens. If I count my longest chain from here now, it's going to be 1, 2, 3, 4. If I count from 1, 2, it's the same thing. If I count to 1, 2, 3, 4, between these 2 carbons, there are bromine molecules attached. 1 bromine atoms attached in each of them. Now look at this. At this point, let's say this is a plane. Both of these guys are attached on one side. If they're attached on one side, we say it is what? A cis isomer. So the name of this molecule, removing the cis, is just 2,3-dibromo. This is bromine in carbon number 2 and 3. So this is 2,3-dibromo 2,18 because the double bond 2-butene, because the double bond is in carbon number 2. Remember, the double bond is in carbon number 2. That's why we say 2-butene. But because this is on the same side, we say it is cis. You put it in front. Usually, if you're going to type it, it's going to be what? Italicized. So this is cis 2,3-dibromobutene. Now, when you rotate this a little bit and poker it, it bends such that this bromine can now be on opposite side. Look at this now. This now, they're in different opposite side. When they're in opposite side, we say they are trans. So in this case, this becomes trans 2,3-dibromo 2-butene. These 2 molecules are different molecules from each other and have different physical and chemical properties as a result of this type of isomerism. No, so let us take that. Let's use some reflection questions to drive home this particular understanding. Now it says, determine if the molecule below exhibits geometric isomerism. If so, draw and name it. Let's see. Let's determine the longest chain. So the longest chain, of course, will be, it can be 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. Anyone. So I'm going to count, and I'm going to count from here because this gives this carbon 2. If I count from here 1, 2, it becomes 3. So the double bond matters here, and then bromine is here. So I'm going to count 1, 2, 3, 4, 5. The longest chain. So this is pentene. That's what it means. Now look at what is happening. In between these 2 carbons now, there's their attachment. There's a bromine and there's another hydrogen. So I can remove this. Okay, if I remove this hydrogen from here and put it here, it becomes an attachment. So I can put it up or down. That's what it means. So there's an attachment here as well. I'm not going to do that. So look at the question. It says, determine if the molecule below can exhibit geometric isomerism. Yes, it can. So I can say, yes, it does exhibit that. If it does, it says draw the 2 isomers and name them. So I'm going to draw the 2 of them and name them. So let me draw the first one. I'm going to draw the first one here. This is going to remain the same. Remember, I'm going to have this one I'm going to use red. I'm going to just keep this one the way it is. And I'm going to put this. I'm going to put this the way it is. I'm going to put this hydrogen here. Now look at this. I refuse to put this hydrogen up because I want you to figure it out yourself when you are doing this, because I believe you have to pause this from time to time. Try to walk through these problems yourself and come back and look at my answers. Now look at this. If I put this hydrogen on top, so I'm going to try to put this hydrogen on top, put the double bond, and my bromine is already on top. Look at that. Both of them are on the same side. Then if I put this gives me a new isomer. So I'm going to count again. 1, 2, 3, 4, 5. So let's name this. How do we, because it says draw and name it. Both bromine and hydrogen is on the same side, and they're attached to the two carbons that have the double bond. So this is a cis isomer. So what is it going to be? Let's name it. It's going to be, I'm going to say cis. I'm going to say cis. Now remember, the longest chain is pentene, but we have attachment. The attachment is what? In carbon number 2, bromine is number 2, and methyl is in number what? 4. Don't forget that. So it's going to be, and so it's going to be 2 bromo, remember, and Br comes before M. So it's going to be 2 bromo, 4 methyl, 4 methyl. The double bond is in number 2. 2, the longest chain is pentene. That is the name of this. And in this case, it is cis. What it means is that the other one we're going to write is going to be the trans. And how do we form that? I'm going to change the orientation of this. So I'm going to take this and put it down. So let me draw that towards this side. So I'm going to draw it here. What am I going to do? I'm going to leave this as it was. And I'm going to leave this also as it was. I'm going to put this as it was. And then I'm going to put C. Now I'm going to put hydrogen down. I'm going to put the double bond. I'm going to leave my bromine here and this. Look at it now. The bromine is on opposite side. So most times, there's a good way I usually tell students to figure this out. If you look at this, you can take this to be, look at this now. This looks like an E. It's a fake E. It's not really E, but let's say it looks like an E. Look at this one now. This looks like what? A Z. Not a perfect Z. So usually that's what you have in trans, like a Z. Whereas here you have like a E. So that can be a very good way of figuring it out. So you can say E. You can say Z. So this is just to help you. Remember, this Z, you have to turn it. This is not a perfect Z. So that's how you can figure this out. So again, let's name it. You know, this is something with this. The difference will be, we're going to put this. So if I take this again, it's going to be trans. Every other thing is the same. 2 bromo. 4 methyl. 2 pentene. Every other thing remains the same. So now we're going to solve some problems based on this geometric isomerism and nomenclature. Let's see. It says draw the structures of the following alkenes. Let's draw the structures of the following alkenes. It says trans 5-ethyl 2-heptene. Now the first thing you need to do here now, remember what I told you. This is going to look like what? Trans will look like Z. So we're assuming we're going to draw something that looks like a Z. It's not a perfect Z. It doesn't matter. So you can. So I'm going to use shortcut to do it. If you use shortcut, the Z tries to appear. Now look at what happens here. The double bond is in number 2. And the T group is in number 5. So I'm going to draw something that looks like a Z. Let me start this. Look at what I'm going to do. I'm going to say 1. This is 1. Oh, I'm going to use my red. So this is 1 carbon, 2, 3, something that looks like a Z. I told you now. 1, 2, 3, 4, 5, 6, 7. Let's see. 1, 2, 3, 4, 5, 6, 7. 7. Now, do you know why I use this Z here? The Z has to be where you have your double bond. So because it's in carbon number 2, so it's going to be between 2 and 3. So that's why I did this. So it's 1, 2, 3. So I'm going to put this double bond at this point. So if I count this now, this is going to be 1, 2, 3, 4, 5, 6, 7. Good. Now what I have ethyl group in carbon number 5. In carbon number 5 is ethyl. So ethyl. So I'm going to put it. Ethyl is, if I take it this way and this way, this is ethyl group. So what I have here now is the trans. Now if you look at it, there are no attachment of on this carbon. What it means is that you only have hydrogen, because already you have carbon here has 1, 2, 3. Here 1, 2, 3. So hydrogen is going to satisfy. So I'm going to try to put those hydrogen with a different color. So there will be a hydrogen here and a hydrogen here. The two hydrogens are placed on opposite side to make this a trans isomer. Like I said, this looks like our fake Z. Look at our fake Z. Remember, this Z side must be between the two double bonds. Now, this will look an L. Look at what I told you. The difference between this and this now is that I'm going to take this and orient it down this way. So it's going to look like our fake E that doesn't have, remember, the fake E I'm drawing doesn't have the middle slash. So it doesn't matter. So let's do it here. I'm going to now change this down to this way. And it's going to be exactly the same thing. Let's see how that happens. So look at what I'm going to do. I'm going to count 1, then 2. Again, I'm going to put this my flat line. I'm going to go 1, 2, 3, 4, 5, 6, 7. So 1, 2, 3, 4, 5, 6, 7. Right? 7. So I'm going to put my double bond here. Remember, it's between 2 and 3. And then I'm going to put my hydrogen. Now, because I drew this thing this way, the hydrogens are going to be placed on this side, making this a cis isomer. And then, remember, this is 1, 2, 3, 4, 5. I'm going to put my this thing in carbon number 5. It's going to be this and this. So this becomes, again, you can number it. So it's going to be 1, 2, 3, 4, 5, 6, 7. And this is the attachment. So this is going to be cis, 5 cis, 5 ethyl, 2 heptene. That is how you draw these structures. Now, we now go to the last but not the least of our problems. It says, name the following alkenes and specify their configuration by indicating cis and trans where appropriate. Usually in exam, I usually try to make it so specific that you have to put the cis and trans for me, right? So when I don't usually specify it, at times I leave it open. If you give me the structure without it, I take it. But when I specify it particularly, you have to give it to me. Okay, the first thing we need to do, we have to identify, as usual, the longest chain. Then, if you identify the longest chain, you now go to the double bond and look for the attachment that will make it either the cis or the trans. Let us do it quickly. Now, if I come here, if I count 1, 2, 3, 4, this is an attachment. Remember, you are seeing an L already. This is telling you that you are seeing, sorry, a Z. This is going to be to your mind now, this might be what? Oh, this looks like what? A trans. Don't be fooled. Don't be fooled. You have to look at it very well and first of all identify the longest chain. Let's see what happens. So if I come from here, 1, this is going to be 2, this is going to be 3, 4, and 5. These appear to be our longest chain. If we can number it from here to 1, 2, 3, gives this 3, double bond 3. So this is wrong. This gives it 2. So I'm taking my numbering is correct. Now, if this my numbering is correct, what it means is that we have methyl groups attached to, remember this CH3, this is CH3. So we have methyl groups attached to carbon number 3 and carbon number 4. That's exactly what it means. See now what is going to go on. Now, the two carbons we're interested is this and this, carbon 2 and carbon 3. In carbon 2 and carbon 3, what's attached in this? Now, in this carbon, now remember, you have methyl group attached here. What it means is that here now, this carbon is going to be 1, 2, 3. To saturate it, you must have to satisfy the octet. You must have to put the hydrogen. So hydrogen and methyl is attached here. And look at it, they are attached on the same side. Does now not interest you now? So initially, you think it's a trans. So that's why I say don't go with. I just go with that to tell you if you're going to draw them from the name. That is the only way you try to imagine that Z and L. It helps you a little bit. But here you have to know. So look at this attachment now. This one now has the attachment on the same side. If it is on the same side, excuse me, this is definitely a cis isomer. So let's name it. Remember, the longest chain is pentene, and the pentene is 2-pentene because it's in carbon number 2. Since it's the cis, let's name it. We use our blue. So this is going to be cis. The methyl group is attached in carbon number 3 and carbon number 4. So this is going to be 3, 4. Since it's 3, 4, it's going to be di. Remember, there are 3 of them. Dimethyl. The longest chain is pentene. And because it's pentene, the double bond is number 2. So it's going to be 2-pentene. Oh, that 2 looks weird. I'm going to take it. So it's going to be 2-pentene. That is it. That is how you name it. So this is cis 3,4 dimethyl 2-pentene. It is a cis isomer. Let's try to name this one. Let's see what happens here. Again, let's try to identify the longest chain. if you count from 1, 2, 3, 4, 5, 6, this is a long chain, but we don't know it's the longest. Let's see. 1, 2, 3, 4, 5, 6, 7. This is definitely the longest chain. And to count it in a direction that gives the double bond the smallest. If you count from here 1, 2, 3, 4, it gives the double bond 4. If I count from here 1, 2, 3, it gives it 3. So I'm definitely counting from here. So this is going to be 1, 2, 3, 4, 5, 6, and 7. So this is what I'm going to do. I'm going to take this. Now, in between this double bond, let's see. Does it have attachment? You have one attachment here. Remember, this is an ethyl group. So what is attached here? Definitely there's a hydrogen here. You see it now. So, and they are located in opposite side. Ethyl is located on this side. This is located in the other side. This is a trans isomer. We've already established that. So let's start naming it. So definitely it's going to be a trans for sure. Now, that's the first thing. The longest chain is heptene, 7. And the double bond is located in the carbon number 2. So it's going to be 3 heptene. We know that already. But let's talk about attachment. Where are they attached? There's only one attachment here. It's methyl group. Remember, hydrogen is not an attachment. It's an attachment, but when you're naming, it's not. You don't have to tell us where it is. That's what I mean. But in this case, in making this to become a cis or trans isomer, hydrogen is an attachment to this. But in naming it, remember, we don't count this as an attachment in the real number, in naming it itself. So what is going to be? We only have, that means that we have only one attachment here, which is ethyl. So this is going to be in carbon number 4, trans 4 ethyl, and then trans 4 ethyl. What's the double bond? The double bond starts from carbon number 3, so it's going to be 3. Longest chain is 7. 1, 2, 3, 4, 5, 6, 7 again. And 7 is hept. Hept, because it's an alkene, it must end in ENE. So this is trans 4 ethyl, 3 heptene. That becomes the name of this molecule with the proper cis and trans configuration. So again, I go through. This is a cis 3,4-dimethyl 2-pentene. Because we have what? Because we have the hydrogen and the methyl group on the same side. I can just help you a little bit with it. So this is on the same side. In this one, it is a trans because we have ethyl group and hydrogen on different side. I can do this. You see, they're located on opposite side. And again, this is trans 4-ethyl 3-heptene, and this is cis 3,4-dimethyl 2-pentene. And having said that, we've come to the end of this lecture. Thank you once again for listening. Bye.